Topic for today is I called it treasures in your backyard, use of local materials for pottery. And the reason, I thought this would be interesting to talk about because there seems to be a growing interest in the use of local materials. I mean, when you think about it, traditionally, potters didn't have any of the freedom of choices that we had. Traditionally, to set up a pottery, you needed a water supply, you needed a fuel supply, because back then everything was burnt, you burned to fire everything, and you needed clay, whatever happened to be in the area. So if you even look at the history of pottery and the whole pottery industry and the pottery technology from the very beginning, is that the types of pottery that evolved across the world were really dependent on the type of local clay. So for instance, around the Mediterranean, the whole Mediterranean region, most of what they had there was low fire red clay. So you evolve a lot. So you basically, this is where the Maiolica technique and a lot of the early pottery was. That's all they had. So they had to adapt. If they wanted to make pots, they had to adapt their production to whatever was available. Similarly, like in South China, they had high fire clays, which is one of the reasons that drove them to develop more efficient kilns, because they didn't have a lot of low fire clay in the southern part of China. The northern part of China, they had low fire clay, so they tended to work toward more low fire things. So people were very dependent on whatever the local resources were in terms of coloration, pigment. They couldn't buy, like we can get cobalt oxide from Africa now, and some of these other things that we can bring in, we don't even think much about it. But they were really limited in terms of whatever their local resources were, and that's what dictated what they were able to make. But I think now we're almost sort of going back the other way, and people are getting more and more, from what I've seen, people are getting more and more interested in understanding some of the natural materials and maybe introducing them in some of their work. And I guess you could ask the question, why use local materials? And I think one of the reasons is there are a lot of people that feel like they want their work to connect to have a direct connection to where they're living or their environment or something, their surroundings. And so I think that's a big part of it, is this almost emotional connection, or they want to sort of have some of the spirit of the local place. There's a great French phrase for that they use in cooking called cuisine de terroir, which means cooking of the dirt, or literally cooking using local materials. So it's that same kind of spirit as you're sort of imbuing your work with the spirit or the connection to whatever's around you. I think, and then there's also the idea of maybe you want to just, you like they're just conserving materials. So if you can get a clay locally or a pigment locally, why not use it instead of buying something? The other thing that I think we've lost track of is some of the unique characteristics that you can get with naturally found materials that get homogenized out in commercial products. And there are some incredible clay bodies, naturally occurring clays and mixtures of clays that have incredibly good properties for a specific purpose. But we tend to use clay bodies, and commercial clay bodies are really made. Clay body is basically a mixture of usually 2 or more clays plus other ingredients like fluxes and silica. But from the commercial point of view, a clay company would like to make a clay body that is useful for everything, because then they can sell the most of it. Instead of making 100 different clay bodies, they'd love it if they could make one clay body and everybody would buy that and just use that one. It's easier for them and it's cheaper. So they tend to make clay bodies that they think have broader areas of application, but then they lose a lot of their distinctiveness. They lose a lot of their sort of peculiarities that might not be good for everything, but might give you incredibly interesting results for some particular application. So one of the things that I've seen is that people are getting interested in using local materials to include the peculiarities of the materials if they can adapt them. This is another reason why a lot of potters, at least that I know, they make their own clay bodies. Because once if you've gotten to the point where you've established a process that you like and a form of work that you like and a color palette and so forth, then you can make a clay body that suits you can design your own clay body that suits your process much better than any commercial clay body, much better. Because also there's a certain amount of subjectivity to this. You're the one that's judging your work. You're the one that's judging how plastic you like it for whatever your process is. You're the one that's judging the color, and color is a really sensitive property. So what you might like, somebody else might not like. So by making your own clay body, you can exactly tune it in to your tastes and your style. And so a lot of potters that I know and different places I've lived, eventually they end up making their own clay. and they may incorporate local materials if they have them available, or at least they're buying raw materials and producing their own mixtures. And because they can really fine to it. And then again, this is another really very personal expression of their own taste. It's part of their artistry. It's not just the object itself, it's the materials that it's made out of. And so some of those really subtle characteristics, they can fine tune them to their process, and you couldn't get them any other way. So they really value the fact that this is another expression of their personality, their taste, and the particular properties of the clay. And I think another part of it, I know one of my interests in materials is just sort of, I'm just interested in exploration and experimentation. I just love to try things. So whenever I'm driving along, if I see a rock or something, I'll swerve over and take my rock hammer and bang a piece off and bring it home and do something with it. And I just enjoy kind of experimenting and exploring. So that's another part of it too, is just kind of, I guess, curiosity, I'd say. What I'm going to talk about is just when I call local materials, you can sort of divide them up into several categories that we can sort of break them down. One I'd call rocks and minerals is one category. Another category I'm calling sort of scrap materials. Not necessarily rocks and minerals. Another ones I'm calling wastes, like organic and inorganics, and that might include like crop wastes and things like that. Plant materials, and finally commercial products, because there's some that are like wastes or scraps from commercial products. So I think I'm going to start with clay first, in terms of local materials. And I guess the clay can come from, there's clay found almost everywhere. I mean, people find it a lot of times. I've talked to people, they're working in their vegetable garden, or they're planting in their garden, and they'll turn up some clay in their garden. You can find it very commonly in stream beds is a good place to look. Road cuts is another good place to look. You don't have to worry about going on private property or excavation sites if they're accessible. It's a great place to look. And then, of course, there are commercial brick pits, places where if you can get access to them, where you can actually, we're actually quarrying or they're mining clay. But there's clay found, and I'll show you later on, but I mean, we found some clay here in the backyard when we were constructing this building. We had to dig a trench from this building to the other building to connect a power line, and I found some really nice clay just in this tiny little trench, and I'll show you some examples of stuff that I did with it. So you can find it, it's everywhere. The thing that's kind of interesting, though, as you'll see as we go along, is the condition of the clay that you find can vary tremendously. So it's almost never going to look like what you buy when you opened up the bag, okay? It's going to have rocks and sticks and dead frogs and twigs and all kinds of other stuff in it. If you're lucky, you might find a vein or a bed of something, especially in a cut or something, of something that really looks like what you're more familiar with clay. But a lot of time, it's just clay that's in this mixture of rocks and pebbles and sand and stuff. And the clay can be extracted, but it's not necessarily be something that you can just scoop a handful out and put it on the wheel and throw it. I mean, that happens, but that's not in a lot of cases, that's not the normal situation. And so what can you do with clay? And I guess one of the things I want to talk about, even if you don't have access to something that you'd say is throwable, or that you can even make a body out of, there's still a lot of other things you can do with it. One thing you can do that I've played around a little with, it can be a clay body ingredient. And so what this implies is you don't need an enormous quantity of this stuff to play with and experiment with. I mean, literally, I've got 2 5-gallon buckets that I got out of the trench here, just 50-foot trench, and that's 5 years supply, 10 years supply for making slips and other things that you can do. So you don't need an enormous quantity. You don't need a dump truck and a backhoe, okay? So one of the things you can do is you can add it, you can just take a commercial clay that you have and take a little bit, and we'll talk more about the processing, but you can take a little bit of this native clay and just add it to it as a colorant, for example. And the other thing that's nice about some of these natural clays is they contain, for instance, a mixture of a lot of times iron minerals, but also other minerals. And when they're making commercial clays, for instance, and let's say they make a red earthenware or something, they're not adding all those other trace ingredients. They're adding like red iron oxide. So again, you can get some really unusual and subtle color variations by using even just the natural clay as the source of the colorant that you can't get in the commercial, because they're just adding red iron oxide, pretty pure iron oxide. So, but some of these other might contain a whole lot of other, like especially manganese. Manganese is fairly common. So there might be traces of manganese in this clay that again would give you different color effects. And you'd have to play with it. You'd have to try different firings and different ways to see what might bring that out. But again, it gives you the possibility of greater variation. You can also add it for texture. You might find a clay, for instance, that, let's say you found an earth, and I'll talk about this later on, but I've taken an earthenware clay and added it to a high fire clay, and now I'm wood firing it. And when I fire it, the earthenware clay actually melts and oozes out of the other clay. And it almost looks like shigaraki. Everybody familiar with that, where the feldspar melts out? Only I've got red metallic things that ooze out of the clay and melt on the surface of the pot. Because the earthenware that I've added and I fired it to cone 14 in a wood kiln. It doesn't affect the body, but it gives this really dark, rusty stain and these things that just ooze out onto the surface, like sort of rusty shigaraki. The other thing you can do with a clay, well, again, we'll talk about processing in a minute here, but another thing you can do is make a slip out of it. And this is probably the easiest thing in the world to do. And as Greg mentioned earlier, the way I usually do this is I'll literally I'll just take the clay, and I don't bother with the freezing and thawing. I just put it in a bucket of water and let it sit, and then I sort of beat it to death in the bucket of water and break it up. And then what I do is I'll just basically screen it. I'll just pass it through a series of screens. I'll pass it through a coarse screen to get out the pebbles and the dead frogs and the sticks and stuff. And then I'll pass it through a finer screen. And I made a couple of slips that I'll show you later that I finally ended up passing through an 80 mesh sieve. And what I collected was basically slip. It was that simple. I just screened it. I mixed it around a couple of times. It's called blunging is the term in the ceramics industry. Blunging, where you mix the clay with water. So I blunged the clay and then screened it to get out. And I just screened it successively finer, and I ended up with a usable slip. Because basically I was removing all the coarse, gritty, chunky stuff, and I ended up with in several cases, a very nice workable slip. And I mean, a lump like this will give you enough slip, that'll give you a quarter slip. So again, you don't need a lot. Even if you're just digging in your backyard and you find a couple of little lumps of clay, that's enough to play with. You don't need an enormous quantity. The other thing you can do with clay is you can use it as a stain. And I've got this, I'll pass this around. This is a sculpture face that I did a while back, and I had bisque fired it, and then I just took the clay slip, which was dug from down in Bethesda. They were doing excavation, and so they dug up some clay. And so I just brushed the slip right on the bisque clay, and I knew that, and you say, well, the clay is going to shrink and crack when it gets fired. I wanted that. I wanted this to look kind of old, so I didn't want it just to be a smooth surface. I wanted it to be kind of cracked when it shrank. So in this case, I brushed it on and then just wiped it off. So in this case, I was using the slip. Normally, you wouldn't put thick slip on a bisqueware because you had, the mismatch in terms of drying, but I wanted it to crack and maybe even fall off a little bit. So in this case, I used the slip as a stain, really, to highlight some of the texture on the piece. So that's another thing you can do with slips is you can dilute them, make washes and stains out of them, and they can just be a stain. Okay? Any questions on that? So going back to the preparation, one of the things, and a couple of things in terms of evaluating, but preparation, again, what I normally do is if I find a lump of clay, like this is the clay, for example, that came up out of our backyard right here. I'll leave it up. Well, I can pass it around. It's in this container. It's a little, but you wouldn't necessarily look at this and say that that's clay. But there's a lot of clay in it. One of the tests that I found works really well if the clay is at all wet, or if I can wet it, is if I can smear it. If I can sort of burnish the clay while it's in the lump of clay, then I know that there's a fairly significant clay content. If it's got a lot of sand in it, you can't sort of polish or burnish the raw clay. But if it's got, to me, what I would consider a usable clay content, I can usually take my stick or just a thumb and I can sort of burnish it and smear it. And I can see that smearing is those really, really fine clay particles that are lining up again, and I can produce that surface. But normally you wouldn't look at that and say, but there's a lot of clay in that. There are also a lot of sand and gravel and pebbles and stuff in it, but there's a lot of clay in it. One of the things, another way to evaluate clay, let's say you just find some clay and you want to decide what it's good for, would be do a fusion test. Take a little piece of bisqueware or something and make a little pile on it, or if you want to, make a little dish or something like this out of clay and fire it and see what it does. Because if it's earthenware and you fire it to cone 6, it'll melt. So part of you maybe depending on what you want to do with the clay, you might say, well, yeah, I'd like to put it in my clay body, but I want to know what it's going to do. Or I'd like to fire it to cone 10, but I want to know what it's going to do. So do a little firing, do a fusion test or a melt test and see what happens to the clay. Does it come through the firing basically unchanged? In which case it would tell you, this is like a stoneware or a high fire clay. Or does it melt? In which case it's an earthenware clay. And so you might, if you wanted to add it to your clay body then, and it melted, you say, well, then I better not add too much to my clay body because my whole clay body will start slumping. So I could add a little bit maybe if it was a red clay for color, but I can't add a lot because my whole clay body will slump. So that's another good, really simple screening test, is just fire a little bit of it and see what it does. Also, it'll tell you whether it changes color. Because in the discussion earlier, the question came up about clays, or the issue came up about clays changing color. And a lot of naturally occurring clays, naturally, contain a lot of organic residues, which typically burn off. And the classic example of that, and you may even see that if you buy raw materials, like ball clay is typically gray, very commonly gray, and yet almost all of that is carbon. And so when you fire a ball clay, it'll usually come out cream-colored or gray or white. So you can't judge the color of the clay, the fired color, necessarily from the raw clay color, because a lot of it may be organics or something that's going to change or something that's going to burn off. Okay? And even the iron, if there's iron in the clay, the iron will change color. If you have a clay that looks yellow, for sort of typical mustard yellow to start, chances are when you fire it in air, that's going to come out red, because that's just a different form of iron oxide. When you fire it, it's going to change to red iron oxide, and if you fire it in reduction, it's going to go black. So again, do a firing test. If you're interested in using it as a pigment, then get an early idea about what's actually going to happen to the clay for your intended use. Okay, I'm trying to think if I had something. Oh, in terms of slip, one of the things I wanted to mention was when you're making a slip and you're applying it, one of the things you don't want to have, I got some dark slip here. One of the things you don't want to have is you don't want to have a lot of coarse particles in the slip. And the best way to judge that is to eat, okay? Because you can feel it with your teeth, okay? So you get some of the slip, and before you brush it on, just taste some of the slip. No, I'm kidding. This is chocolate syrup. But the point I was making is that the point I was making was that you do want to, depending on the use you're going to do with the slip, you can do it. You don't have to eat it. You can feel it. You don't want a lot of grit in the clay, especially if you're going to burnish it, because you'll never be able to burnish the slip even if it has any noticeable grit in it. You'll just be scrubbing the grit across the surface. So you're really doing, and I'm sort of kidding, but I'm not completely, because as a geologist, this is the way we used to judge the rocks in the field. You'd bite a piece off and you'd chew it, and you could feel the way it broke down as to, you could judge the particle size and stuff. But you don't have to do that, because I've gone through 3 sets of teeth. Or no, yeah. But you do want to make sure that if you're thinking about burnishing it, that it doesn't have any really fine grit in it. And I mean really, really fine, because that's all it will take will be to destroy. You'll sit there and try to polish forever, burn, and it'll never happen if it's got any of that fine grit. The one thing that's always interested me about clay is, to me at least, the single most sensitive property that we see when we make things out of clay, you know what it is? What property is the most sensitive to tiny little changes in the chemistry of the clay or the glazes? The color. The color is that mechanical properties and plasticity and all of that stuff is far outweighed. Color is incredibly sensitive to small changes in composition. So this is one of the arguments in favor of using natural materials, that you might get a subtly different shade, let's say, of red or brown by using a natural clay to give you a color than you would by using pure iron oxide. And maybe that's not important, but it's an opportunity or a possibility. And certain clays contain significant amounts of some of these secondary elements, and you can get some really unusual effects. And what you'd have to do to duplicate it, if you wanted to, you'd have to go back and have it chemically analyzed to find out what it is, to say, okay, how much iron do I add, and how much chromium, and how much manganese? This is naturally occurring. And again, you've got all the advantages that we've talked about. You're connecting it to your area. So you might be able to produce pottery that's really unique, not just because it embodies your style, but it incorporates your area, and it represents you as a potter and your location. So that's the argument anyway in favor of it. let's move on to, and I'm going to come back. Some of these things that I've got up here, I suggest if you want to come up and look at them later, because instead of passing a lot of stuff around, I left them up here to look at. And I've got examples of some glazes made from rocks, several different glazes made from clays, a couple of things I'll pass. I'll get to this. So you're welcome to look at these. This is, matter of fact, as long as I talked about it already, this is the slip made from the clay that I dug up out of our backyard. So this was fired at cone 10 reduction in our gas kiln. And this clay, this was the color bisque, when it was fired in reduction, came out dark brown to black. And I got a quart of slip from about 2 pieces this size. And I wanted to try it, so this was cone 10. I've got some other slip I'll show you that I fired at cone 6 and some other fired at earthenware, but this was cone 10 reduction. And it's just this, the glaze over it is just a celadon. Okay, rocks. Well, there are all different kinds of rocks around. There's granite, there's limestone and dolomite, and these are either things that you can find around here. One of the things I'd suggest, if you're interested in rocks but you don't know much about them, if it's a dark-colored rock, it's probably might give you more interesting results than a light-colored rock. Because if you, aside from all the melting characteristics, but if you're interested in getting some colors or something out of it, more likely the minerals that are in a dark-colored rock are going to contain, again, the same kind of minerals like iron, manganese, chromium, and so you might get more interesting results from a dark-colored rock than a light-colored rock. So some of the dark-colored rocks are basalt. They're right. I was telling Jenna a while back, right here on 340, just before you cross Catoctin Creek, even right up on the road here, just on the other side of the road, there are 2 kinds of volcanic lava side by side in a road cut, and one of them is basalt. And basalt is this is the kind of, you heard about the volcanic eruptions in Hawaii. That's basalt. And so we've got some right here in Maryland when there used to be volcanoes here. And that's a really nice glaze ingredient because it contains a lot of highly colored dark minerals and it makes a great glaze ingredient, as an example. But one of the things I guess I wanted to mention, when you think, now rocks are different than clay because you think about, well, how am I going to convert this rock into something I can use in a glaze? And the problem is, unless you've got a ball mill and unless you've got some crushing equipment, it's really laborious. I've ground some rocks in mortars and pestles. I got a mortar and pestle in one of the home decorating stores. It was a rock, carved out of a rock. It's about this big. I was going to bring it in, but it weighs about 25 pounds, so I decided against it. But you can do some hand grinding, but you'll never be able to make enough stuff to do anything, reasonable with. So, and so that's one aspect of it. The other thing is some rocks aren't worth using. Like there's a lot of limestone around here, and limestone is whiting, that's the glaze ingredient. But is there any point unless you're really attached to local rocks, is there any point in going through all the labor of grinding up limestone when you can just buy whiting? I don't know. There's a lot of, but the thing you can do is, if you don't mind this sort of detour out of purely digging it out of the ground yourself, you might be able to buy the lime that they sell to put on your lawn, and it's quarried locally, and they do the grinding for you. And if you buy lawn lime, or what they call dolomitic lime to put on your lawn, that's just ground limestone. And so if you can find a place in your area that sells locally made lime, then that is your local limestone. It's just they've done all the grinding for you. But I mean, again, there are a lot of different kinds of limestone around it. What's really interesting is right down the road here in Millville, there was a quarry where they dug, where almost theoretically pure dolomite was quarried, and it was incredibly valuable to the steelmaking industry, and they used to ship it right down the road here to Pittsburgh. It was incredibly valuable raw material because it was very, very pure dolomite, which was very unusual, actually. It wasn't just dolomitic limestone, it was very pure dolomite, and it was considered very valuable. But there's a lot of limestone around here. And it's quarried. But again, is it worth you grinding it up? I don't know, if you like doing something like that. But you might be able to find a source in the region, at least, that does the grinding for you, and then you could use it. Well, what can you do with rocks? Well, one way to use them possibly would be, or to be able to have access to them, is if you can get a powder. And I was really fortunate. I lived in Maine for a while, and I had a shop on an island, Vinyl Haven Island, which is in the Atlantic Ocean off the coast of Maine. Well, there's an ancient granite quarry there. And they had reopened, and a lot of the granite from Vinyl Haven Island was used in the Capitol buildings down in Washington. But they had reopened the quarry, and they were cutting the granite with saws. And so I got the sawdust, the granite dust, from the granite quarry, and they were glad to get rid of it because it was like sludge. They had to pay to get rid of it. So I said, I'll take it. So you can look, so I've got them up here, you can look at it. This was the granite that they were cutting, and I made these 2 glazes from the granite dust. So I didn't have to do any grinding. I got this really nice, fine powdered granite. So as an alternative or something sort of related to that is go to companies that prepare monuments, like like graveyard monuments, or places that are cutting countertops, and see if you can get the sludge, because they don't want it either. Is that they're using diamond saws to cut it, so you don't have to do any grinding. It's just ready to use. So if you can go talk to countertop places, and go talk to monument grinding where they do sandblasting and collect and see if you can collect the dust, because a lot of times they just want to get rid of it. So then you don't have to do any of the grinding. Now the other alternative is sometimes you can find areas where the rocks have naturally kind of broken down and decomposed. They weather. And there's a good example right over here on 340. This is one of the kinds of, this is basalt. Or this is actually, it's called metabasalt because it's been metamorphosed. But I also found in the same outcrop, there was an area where the rock had cracked and it had broken and it had been weathered and water had been running through it. And so it turned into that. So I collected, I've got a bucket of this stuff. So this stuff, I'll be able to grind this up. I can almost just crush it with my fingers and I'll be able to use, and now the chemistry may have changed a little bit because it did weather, but it's probably still pretty close. So I'm going to play around with this as a glaze ingredient, and I think it'll give me something close to this. But I'll pass these around just so you can see the difference. So this was weathered, and there was a band about an inch and a half wide in the middle where this had gotten crushed and weathered, and the water had run through it, so it had broken down the rock. So I don't have to grind this up. I can just crush this a little bit. This will be easy to do. So that's another thing to look at. I'll pass this around if you want to look at it, see the difference, is that a lot of times, if you find an area where there are exposed rocks, you'll find an area where the rock has been weathered and broken down, and it's a lot more powdery and a lot more usable than just this really hard rock. That's another thing you can do. So yeah, so that you can sometimes find rocks that when they're naturally occurrence where the rock has kind of broken down and weathered. And there are several examples around here where the rock itself is really hard and durable, but you can find portions where it's gotten crushed and weathered naturally, and you can almost just dig it out with your hands. So it's a lot closer to being usable than trying to dynamite it into small pieces. One of the things I suggest that I mentioned earlier with clays, I also suggest doing with the rock is do a fusion test, do a melt test, because if you're going to use it, be nice, even if you don't know exactly what it is to find out, well, where does it melt if you fire it to whatever temperature and or not. So I'll pass this around. This is a sample of basalt in a little dish that I made. This is reduction fired because I also wanted to see the color. That was fired to cone 10. It totally melted at cone 10. This was basalt. This is another sample of a schist that was from around here. And this didn't melt completely. You can see it partially melted, but it didn't melt it. So this tells me if I want to use this, let's say I want to use it as a glaze ingredient, it helps me to know that, okay, the basalt completely melted. I'm not going to have to do a whole lot in terms of adding other things to it to turn that into a glaze, because by itself it's almost forming a glaze. Whereas this one, I'm going to have to do more. I'm going to have to add some fluxes or something to it. So even if you don't know what it is, this can give you a big clue. And another kind of, if you don't think about it as a rock, but I included in this section, is volcanic ash. And volcanic ash is basically, I mean, if you have access, like if you can go out and, are you going to be anywhere, like if you're anywhere near, like when we had the eruption out west. What was the volcano that erupted? Mount St. Helens. So if you have Mount St. Helens ash, you can make a glaze out, because Mount St. Helens ash is almost the same composition as granite. And it's a fine powder, so it wouldn't take a lot of work to grind it up to make it usable. Or in some cases, if you had enough of it, you could probably just screen it and take the finer stuff and use that as your glaze ingredient. So volcanic ash from anywhere, just about, is a really usable glaze ingredient. And it is. It's just a finely divided rock. Depending on the kind of, it might be a basalt kind of ash, or it might be more like a granite composition, but it's basically the same as either basalt or granite. So it could make a really good glaze addition. I'm trying to see if there's anything else I had here. Anyway, so the main thing I suggest with the rocks is either if you can, unless you have access to do a lot of grinding and powdering, is see if you can find forms of the rocks that are already kind of rotten or broken down, and then you're well along the way to making them usable, like the rotten rocks. You can see how powdery how flaky that stuff is. You can just it's like sitting there crunching styrofoam, popping the styrofoam balls. Yeah. Somebody take that away from her.